Hey everybody, happy Tuesday. We are back on a regular schedule this week. Excited to be here. Got a couple of things to share. I'm actually going to start with some fun goodies. So a little bit of an unboxing moment. So I'm going to slide over here to the desk because I got a couple of things I want to put on the big screen for y'all to see. One is this, the Asus Tinker board. So this showed up. Let me get the brew stuff out of the way. And I will I'm gonna pull this open so we can mess with it a little bit. So this is the Asus Tinker board that I mentioned, sort of the quad core system on a chip from Asus. It is a complete. Hey Doc Kami, how's it going? Happy Tuesday. Hope you're having a great week. Just doing a little bit of unboxing of some hardware here real quick to show this off. I'm thinking we should mess with these on future streams, but this is the Asus Tinker S, and you'll notice it has sort of the Raspberry Pi compatible 40-pin header here. Good looking PCB, honestly. So look forward to messing with that. It has the same sort of camera pin connector. Oh my gosh, I'm like hard time with the camera, let it autofocus. So that's pretty cool. I'm excited about that. And then the other, the one I'm like super triple excited about is just showed up like an hour ago. I haven't even pulled it out yet, but it is a Coral dev board with that Edge TensorFlow processing unit, or TPU. So this is the dev board from Google. Like I said, I haven't opened it yet, so let's open it now. Break the board. Pardon me. So here's a nice little getting started guide. One of the things that I've been most excited to see, here, let me move the camera up. Come on, man. One of the things that I've been most interested to see is what this thing looks like with this. It's got this fan and heatsink on it. So it also follows sort of the Pi hat sort of form factor, 40-pin connector. But look at this, it's got this giant heatsink on the SOM, on the system on module here. That's their proprietary little compute chip and everything. So that's kind of cool. Here's the two sort of side by side. Got the Asus Tinker and the Coral. Man, that heatsink is, I mean, see how tall that thing is. So I'm thinking in a future stream we need to power these things up. Clay, yeah, the Coral is available. So I pre-ordered it on Mouser a couple of weeks ago, and it showed as back-ordered for a while. And what do you know, all of a sudden, our pre-order showed backorder for a couple of days, and then just miraculously it showed up. Said last week that it shipped. So, hey Grogard, hello. Hey again, Clay. Glad you all are here today. So, like I said, I think a future stream needs to be dedicated to getting some of these boards online and messing with them a little bit. I'm really curious about the TensorFlow Lite stuff in the Coral boards. Just, running through some of the examples and, seeing what's available there. So, it should be good fun. All right, let's get the brew buddy back in here. That, I'm going to get back to today. And, it's going to be difficult with focusing again. But yeah, I'm pretty excited about those boards. So just wanted to share a bit of a hardware preview with y'all. All right. Hey, Rhinosaurus Rex. Hey, how's it going? Happy Tuesday to you. So if you all recall, here's where we ended things on Friday. We spent some time setting up Electric IO on the Brew Buddy, and then I sort of hit a stopping point with that when I was trying to call back in to Electric IO, if you'll recall. We had things working in terms of publishing from the Particle Device Cloud, to Electric IO. Where I hit a wall was sort of adding buttons to my Electric IO screen that would allow me to call back in to the Particle devices. And did my homework on that, not off stream, because y'all aren't here to watch me read docs. I mean, not a lot, at least. So spend some time checking that out off stream. And the reason, or in order to get that to work, I actually need to use MQTT on my Particle device, which is totally fine. I absolutely can do that, and we'll probably spend some time. In fact, that's one of the things that I want to spend some time on today. So I got back into my Electric IO dashboard and cleaned things up a little bit. I added the obligatory, I love that Suze, that NoOpCat has added support for sticker cards. So you can add a sticker card and add an animated GIF. So of course we had to do that. The dog drinking beer. Fantastic. So, and then I added, moved some things around, and then I added a few buttons here these are going to represent calling some MQTT endpoints to start brew, start fermentation, and then to stop everything. So I think that's what I'm actually going to spend some time working on today. And it's going to require installing an MQTT library on firmware, and then it's going to require figuring out sort of the right Azure endpoints that I need to call. So if you go and look at sort of understanding how to work with IoT Hub direct methods, because that's ultimately what's happening here. Electric IO gives you the ability to call a direct method on the device twin in your Azure portal, right? So this is the facility that enables that. So I just sort of need to figure out the right endpoint, authorization, all that fun stuff. So we'll spend a little bit of time back and forth on some of that stuff here today. So the other piece, and we can get into this with firmware depending on how things go with the IoT Hub and the MQTT stuff. The other piece, and I spent some time on this at the end of the stream last week, was displaying a voltage level on the device, and that's actually in the upper right hand corner of the screen. Unfortunately not, man, that is just not. I wonder if it would focus if I put my hand on it. I'll make that a little bit bigger so that y'all can see it. I want to finish that piece up to just show a bit of a battery reading, a percentage. Right now it's just showing the raw voltage reading, so we can come back around to that. Oh, not that. So yeah, let's go ahead and get started. And I'm going to start with actually getting this MQTT library installed. So pretty simple library. This is just going to be a matter of me adding a MQTT client, pulling in the library. Make this a little bit larger so y'all can see it. Pulling in the library, adding an MQTT client, and then listening to a subscribe message. So one of the things that's not here right there, and where I was hitting at last week was, in an ideal world, I would love that if the IoT Hub would work with Particle Publish and Subscribe, and I could subscribe to a message that comes back into the device, but that's not built in. I believe the IoT Hub right now just uses MQTT, although it may use a QMP as well, or AMQP. You don't know what I'm talking about. One of those two. But that's okay. Thankfully, there's MQTT support on Particle devices. So I'm going to start by installing that library. So back in Visual Studio Code and install library. Let's just go to the main view for now. Get the screen out of the way. So I will go to Particle install library and install the MQTT library. If all goes well there, that should show up in my list. So cool, I have the MQTT library. Let me verify it shows up in my project properties. Great. that dependency is there, so I can use it. So I'm going to start with including it, naturally. And I'm going to make a comment for why I'm doing this so that I remember in a month when I forget. Anyway, how's everybody's week going? I know it's only Tuesday, but hopefully y'all had a good weekend and a good week so far. So include MQTT.h. So I will need to specify a payload and a client, right? So let's do that a little bit further down. Let me give myself an item in action here. Rhinosaurus Rex work laptop. Your work laptop graphics card melted, so picking up a new one, so that's fun. That stinks. I'm sorry to hear that. Is it an old work laptop? Like, was it due? Was it due and now you get the latest and greatest, so that's pretty exciting? Or was it one of those terrible inconveniences with new hardware kind of things? Three years old. The old 3 years old. Are you on a three year cycle for getting new? And Clay, you've been writing docs for work for the last 2 days. Are you happy about that, or are you ready for something else? Yeah, there's time after 3 years. My last company had implemented a 4-year. Like, talk about penny pinching. They were trying to implement a 4-year rollover for laptops. No, that doesn't work. Clay, you made a Docker cluster with chips over the weekend? Please tell me that you took some photos of that, because that sounds awesome. That is so cool. Rhinosaur, so you're 3 weeks out from a new one anyway. So, all right, so here's derailment number 1, because of course this was gonna happen. I met a guy recently in Austin who used to work for Cray, and he works for another startup now, and he created this thing called the Terrible Cluster a couple of years ago, and it is a cluster of Raspberry Pi Zeros that he created a case for, and the whole deal. The Terrible Cluster of Pies. So he created a PCB for this, created a very, very like close form fitting. There's a fan on the back there. This thing is awesome. And he brought it to this like hardware meetup that I did a while back. So the thing is really cool. Yeah, it's pretty neat. So I'll post the project in chat. And by the way, Hackaday.io is an amazing source for such things. But the terrible Pi cluster is pretty sweet. And then Clay, send some photos. Oh, cool! Appreciate it. That would be great. And then Ryan, I've been coding on an Azure VM in the meantime. Really? That's hardcore right there. Yeah, .com. It's a pretty cool thing. This is why I love getting derailed, because I can share cool stuff with y'all that I come across, and I love to see. All right, so I added that. Oh yeah, so the next piece is I need to go in, keep work stuff off your desktop. Yeah, that's smart. All right, so here's where we need to go. I'm just going to do it here at the end, just because it's, this code needs to be refactored and cleaned up a little bit for sure. So this is going to be my callback. I'm going to give it a different name. We'll call it, I'm going to need a couple of these, won't I? Oh, no. There's going to be one of these for every. So I know for a fact, based on what I set up here, I'm going to have three different methods. But this is going to end up being the topic name. Start brew, start ferment, and then stop. So my callback here, I'm just going to call it MQTT callback. It's how original. And so now I am not calling eclipse.org. I need to find out where the Azure IoT Hub wants me to call. Fully qualified IoT Hub name .azuredevices.net/twin/device /methods. So IoT Hub name, right. So this is ultimately what I'm going to need to do. Method name will be reboot. Is that right? All right, let me think about this for a second here. No, actually, okay, so I'm subscribing to... Okay. So this should end up being the topic that comes in. And then a payload. All right. This song sounds like something straight out of Toe Jam and Earl. Did y'all ever play the original Toe Jam and Earl, or get the re-release that they just did via Kickstarter? Hey Siva, how's it going? Happy Tuesday to you. Am I directly accessing the IoT Hub service APIs? Yeah, I am at this point. What I am wanting to do here is just do an MQTT publish back in to my particle device. Yeah, you're thinking Toe Jam, not just, okay, cool. Yeah, I backed that Kickstarter, their Kickstarter campaign. It was what, like two and a half years ago? I mean, it was so long ago that there was no Nintendo Switch when they announced their campaign, but I was gonna do it for just get it on Steam anyway. I backed it, and then they finally shipped last week or week before last, and they created a Switch version. So I paid like $5 extra to get the Switch version, and oh, it's so much fun. And this is after my kids got me the Sega Genesis Classics for the Switch for Christmas. So I already went and had played, you know, the old original 1 and 2. It's fun time, fun games. So it looks like the endpoint that I care about here, if I get the right tab, it's going to be this. IoT Hub, AzureDevices.net. That fully qualified to that point. So give me like an MQTT example, why don't you? Let's take a look at some code here. Yes, using the device SDKs. Sure. Show me some C. Okay, IoT Hub client. Let's see what we got here. I hate reading code. Oh, come on. Show me what I'm looking for. This is not helping. See send and receive messages. Yeah, Steve, ultimately what I'm looking for at this point is just an example of the endpoint. Like I want to make sure I put the right endpoint name here in the MQTT service, right? So here's the client, blah, 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 blah. Okay, so the connection string for node is different, and that's fine, that makes sense. So I want to replace this with sort of the right, I mean, is it, we don't need to connect the endpoint. Yeah, okay. So ultimately, Siva, what I'm looking for is, this is from the example code, right? So I'm assuming my client needs, the question is it this? Is it just, right? Brew buddy hub dot Azure devices.net, or is it that plus /twins/ right? Do I actually need to pass in the device name? Because then at this point, everybodyhub.azuredevices.net. That client.connect is not going to allow me to connect because I need to actually pass in some additional. Siva, can you throw me a URL for what you're talking about? The example code, was I just there and I jumped off of it? Is it here in the SDK? Replace this line with your devices. Okay. All right, thanks. Yeah, I'm looking for an example of the connection string that I need that's specific to Azure. Okay. Yeah. There we go. Thank you. Yeah, all right. So, okay, yeah. It's on that same doc and I just totally glossed right over it. So thank you, Siva. I appreciate that. Device cannot use the SDKs. It can still connect using the MQTT protocol on port 8883. So that's helpful. In the connect packet, the device should use the following values. For the client ID field, use the device ID. For the username field, use IoT Hub /device ID /API version. For example, yep, Contoso, devices, / my device. So here, and that's fine. I know my device ID. I'm not going to hard code it for long term, but I will. You can actually get it programmatically, but I will, just for testing, save me from one less thing to get distracted by. All right. So then, So then the thing okay, the connect packet. So in the password field, use SAS token. I feel like I need, okay. Okay. All right, so I think the thing that I'm missing, okay, so I actually need to add, I need to add this header, ultimately, to the connection. So let me take a look at the MQTT. Because I need a little bit more guidance here on how to actually connect to that server. See if the library actually includes something in the header. You're saying I can get the connection string from VS Code if I want to do auto provisioning. Installed the Azure IoT extension to copy connection string from VS Code and using the connection string to pass as parameters for the Node.js device SDK. Okay. That's helpful, Siva. I think what I'm trying to get at here inside this firmware library that I'm using on the brew device itself is how I can do, here we go. Connect with a username and password, that's it? Surely not. Surely I am not limited just to username and password. All right, I'm gonna look at the source actually in Visual Studio Code, so I'm not looking at. So I can set a QoS, that's fine. This username and password piece is interesting to me. Okay. And now I'm starting to wonder if this MQTT library that's inside of the firmware libraries repository is not robust enough to do Azure IoT Hub connections. Dodo121314, thanks so much for the follow. Appreciate it. Welcome. Just here hanging out, muddling through some MQTT stuff in Azure IoT Hub right now. So Siva, to your comment, if I have the Azure IoT Hub extension, if I actually used, generate SAS token for IoT Hub, is that what you're talking about? So let me do that. Secrets mode. So if I do generate SAS token for IoT Hub, enter expiration time, 72 hours. So Siva, so are you saying that I can actually use this shared access signature SR equals, and then use that as the, oh, my audio is loud a little bit. Turn it down a tad. Okay. So are you saying that I can actually use this string as my endpoint for the MQTT service? So here, for my MQTT client, this entire, all right, rock on. Thank you. Yeah, no, I mean, that saves me from, let's find out. So once I got past that step now, I saw that reference to that, to using it from a module. And then I have the same tab open like 3 times here. Oh, okay. So I need to keep that endpoint. Well, what's the module ID though? Set the client ID to device ID. Use the SAS token associated with the module identity as your password. Okay. Now I'm on the trolley. So what you're saying here is this is actually my password. But what is the, so I have a device ID, what's the module ID? So it's copied in the right place. So client yeah, that makes sense. What I'm wondering is, do I need to specify a module ID? Because I'm connecting a single device. Mm-hmm. Yeah. So if you're using an IoT Edge device at the time, we need modules. If you're running directly from a Leaf device, we don't need it. So in that terminology, this is effectively an in-node device. This is not a edge device, or yeah. So what I'm coding right now is an MQTT subscription from an endpoint, from an actual device. I'm ingesting data using the particle integration, which handles all of those, handles all of that for you. What I'm trying to do now is actually call a device method from the Electric I/O dashboard, which routes to a Azure IoT Hub. This invokes a device method, and then use MQTT to actually do a subscription handler to that topic back on the device itself. So here what I'm looking to do is actually just to connect to the MQTT server. So this is my case here. If I'm using MQTT as a device, this is ultimately what I'm trying to do. So what I am struggling with now is, okay. I think I'm on the Charlie. It was in the same spot. I mean, I'm ultimately trying to I'm passing in my device ID API version, passing in the callback, and then when I call connect, right? Connect has a couple of different, what do I use for the user field? Maybe just nothing. I'll just do null for user, see what happens. I'll have to escape all kinds of crap in here. What is happening? Oh. Never mind. Okay. Okay. Possibly closer. So does client.connect actually return anything? It returns a Boolean. Cool. All right, and then let's just publish a message saying, connected or failure. Now the music is very much Super Mario Brothers, right? Let's compile, see what happens. Siva, I appreciate the input on this. This has been super helpful. Like I said, most of my past experience with Azure IoT Hub has been on the ingestion side only. So this is just now that I'm trying to mess with this idea of pulling, sort of calling back into a device. I think I just got warnings there, right? Did it work? Yeah, it's good. All right, let's flash the device itself. Brew Buddy 3. Switch to the camera. Failed to flash? Why'd you fail to flash? Did a local build. Okay, where's my error here? Let me set myself up for local builds here. OS 090. Oh, what? That's interesting. Why not? Huh. Saying it couldn't impute. Really? Yeah, Siva, oh yeah, so you're doing the IoT Hub for your day job, struggle understanding the docs. Yeah, the docs are, in a word, verbose. The docs are verbose. It's not a bad thing, necessarily, but I do appreciate you helping me figure some of these pieces out. I'm curious, Siva, have you, and I'm guessing that IoT Central probably wasn't released until after you all started down the path towards IoT Hub, but have you evaluated IoT Central as well? And if so, what are your thoughts? Oh, 13 problems, huh? Well, hold on. Okay, am I spelling something wrong? Did I include the wrong MQTT.h? You're seeing it. I'm seeing it, right? Oh, you're using IoT Central only, so you're not using IoT Hub. Okay. I am confused. I did install the library, did I not? I'm losing my mind. Include MQTT.h. What is happening? Why can't it open it? Please update your include path. Well, but that's not. Sure. Dashboards reporting, definitely. I don't know what's going on with Visual Studio Code right now. I mean, are you kidding me? It's just a matter of unloading and reloading the workspace. Oh, I forgot to turn my code chat listener on. So if y'all have not seen this yet, feel free, if you notice anything in my code here that is remiss, that you can actually use the line command to say, hey, Brandon, line 21, what the heck does that do? Tell us all about it. Uncomment or unhighlight with 21. This is from a awesome streamer named Clarkeo. That y'all should definitely check out. He built this extension, but it's a fantastic extension. I highly recommend y'all checking it out. All right, where are we? So now the include is working, because of course it is. It's just a matter of reloading my workspace. So let me try local compiling again. And I think we're okay now. No, we're not. Is it possible that this MQTT library just like does not work? I am so confused right now. That's nothing new. I know. No, I didn't unclose the comment. It's right there. No, hold on. So this is very weird. Something here about this MQTT library is giving me all kinds of fits. Or maybe it's something else altogether. That's what I have to figure out. Okay. No, it's the library. So let's pull these lines back in one at a time and see what happens. So that worked. That one's okay. And you know, frankly, maybe I'm just... Maybe it was a bad reference on my part. So I create the callback. And maybe this is my issue. I can't call it that. No, that gave me an error. Alright, there's an error in there somewhere. So... my callback is okay. Is this somehow having an issue with... Oh, you know what? I wonder if... Is it possible that the client just wants that? A port. And then... callback name. Or is it flipping out because I haven't actually... I did the forward declaration for the client for the callback, but I didn't actually define the callback. Yeah, I bet you that's the issue. That's the thing it doesn't like. Maybe. So I'm just going to do a very rough test data, that's all. Yep, looks like that was it. I had my forward declaration, but not the actual. So I think this is what I want. All right, one step closer, and let me pull this out. We'll flash and see what happens. Oh wait, I wanted to change this. So if that works, and looks like it did, great. So let's flash, now let's actually flash the device. Oh, I missed. The Michael Jolly, thanks so much for the follow. And for showing me that I need to actually increase the spacing on my bottom and right there. I appreciate that. I appreciate the follow and for the edge case testing for me. Welcome. I'm here messing with Azure IoT Hub today. I have this device on my desk that is connected to a particle Argon, publishing some home brewing sensor information through the particle device cloud to the Azure IoT Hub. It is wired up to this wonderful electric IO dashboard from NoopCat. And I love it when I switch to this. It puts this like cyan sheen on my face. And now what we're working on is actually using MQTT to be able to call device methods from here back into a method on the particle device. So that is the fun that we are having right this minute. I'm getting some magenta flashing, which is great. Okay, good sign. Good signs all around so far. I'm gonna notice here, hold on. Still going. All right. It's coming. There we go. Come on, come on. Success. That took a second. I wonder why. All right. Okay. And maybe, so this wraps up when I get a version and status messages. And maybe if I'm lucky, failed. Okay. It failed to connect to IoT Hub. Okay, do I have the right? All right, so it's, oh shoot, for that matter, do I have the right Azure IoT Hub? Double check that. Okay, I have a device ID, that is correct. It's interesting that it says it is disconnected, however. I'm gonna go ahead and trigger brewing on here so that it just starts publishing data. Okay. See what else I can do here in Azure IoT Hub. Yeah, sure, select IoT Hub. Everybody Hub, that's the right name, Everybody Hub. So everybodyhub.azuredevices.net. So if I did, if I just do this again. So I think, so this is the right password, right? Assuming, yeah. So here's a password string. I'm wondering if I need to actually provide a user. Yeah, there it is right there. Okay. All right, so that's where I messed up. I need username, use hub hostname / device ID / API version. So right there is my username as well. It kind of makes me think, do I still need to connect to that exact same client endpoint? Or here, let's find out. Let's go ahead and flash. I can't say if this is a false sense of confidence, but I do feel as though we're getting a slight bit closer on this. However, what I am wondering at this point, if this doesn't work on line 104, is if what this should be is just the host name. Right, if this needs to go away and it just be everybodyhub.azuredevices.net. And I just noticed another mistake that I so much better at reading documentation when there are not people watching me. Really, I promise. The client name is the device ID. Should have done that. We're muddling through. So now I gotta go flash it again. And I suspect that this is gonna be correct. Let's find out. All right. I'm feeling good. I'm feeling like we're getting closer. Username. Yeah. Okay. Client ID. Blah, 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 blah. Should be. Let's see what happens. Here we go. Show me success, maybe. Failed again. All right, well maybe I shouldn't have taken, did I take that whole piece out? With the device ID and the version. I mean, all I should need here is the host name, but I suppose it's possible that I need to have this fully qualified name. Doesn't seem right. It doesn't seem correct to me. So the port is 8883. And then the connect packet here. Here looks good. Yeah. Okay. Just fail again. 406. Ah! It's failed in both cases. Gee, I'm very curious. So see with the parameters of client. Maybe I need to do disconnected instead. Maybe he's not implementing it properly. Let's try this. So see the parameters are an ID, username and password. So if a few different options here, right? But ID, username, and password are the specific ones. You're passing in which I'm assuming, given this document, is client ID. So I'm using the device ID. Second is the username field, which is going to be hostname / device ID / API version. And the third password field is the SAS token. And so this is the exact content of the SAS token here. So I'm going to Cloud Flash again, because I changed this to use is connected, thinking maybe I'm getting the wrong info back from the library. So let's try let's Google. I know that there's an SDK there. I mean, I suppose I could just use this. Maybe I should just use the Azure IoT device SDK. Because at least then I know what I'm getting, as opposed to flashed again. I can install the SDK if I have to. If I have to. Wanted to use the lightweight MQTT library, but it's okay. Failed again. Although I feel like I'm signing myself up for more work to do this. Yep. Save for later. I might table this one for the next stream and get back to just fiddling with firmware. So that y'all don't have to watch me bang my head against the wall, because I will use this SDK, but it's just going to be a matter of downloading, building it, installing it. I'm trying to look at the not great docs here on using it. There's a lot of docs here. device SDK samples. And I've already been here once today, right? So client. Okay, how about this? Client sample MQTT. Yeah. So yeah, Siva, this is the MQTT library that I'm using now. And it is actually was ported specifically for the particle ecosystem. So it works with the particle photon, electron, and then the new Argon, boron, xenon. And the idea is it's meant to be a very, very lightweight library. Because this is ultimately where I am. Like this is ultimately where I'm at. Like I'm not having to use MQTT to publish data, only to subscribe because of sort of the current state of the Azure IoT Hub. It's not a bidirectional connection to the particle device cloud. So Likert Boy, hey, in a while loop that's controlled by the user ends with what kind of value? Any idea? It's a good question. I might need a little bit more context from you. What are you talking about? A while loop that's controlled by the user? Siva, yeah, there's definitely some piece of secret sauce here that's missing. I feel like we're closer than we were a little while ago, but maybe, I mean, I'm wondering if my client, client initialization in the context of this library, the example is just an actual server endpoint and a port. And I think that's what we need, not the entire connection string here. So brewbuddyhub.azuredevices.net. Let me try to do that again. Cloud Flash again. Cake.js, hey, how's it going? Hello to you as well. Is the Azure stuff part of getting things to work with Electric IO? Great question. It is and it isn't. So Electric IO uses the Azure IoT Hub. And what I did on my stream last week was the inbound side of that. So actually getting data from the particle device cloud into the Azure IoT Hub. That part is super easy. That part was actually all very easy to set up from the particle device. And really from any device, you would use MQTT for other devices as well if you're using like an ESP32 or something like that. On the particle side, I set up an integration to the Azure IoT Hub. Like, let me show you a couple of ones that aren't being used anymore. I set up this integration, it publishes a payload, and everything's good to go. That allows me to get data from, in fact, you'll see there's a reading right here. And let me turn it back on so that it'll start publishing stuff again. That was all it took to actually get Electric IO working on the ingestion side. The challenge, or where I'm at right now, is that in order to get these buttons to work, so I have functions here in the particle device that allow me to do things like starting the brew process. Oh, it's flashing, that's why I can't start brewing. Functions here to start brewing and things like that and end. And I want to actually wire those up from the Azure IoT Hub to my ultimate device, which is something I've not done before. And this is where sort of the complexity lies, because it's requiring me to implement MQTT on the particle device to subscribe to those messages. And MQTT on particle devices is easy, it's fine, there's a great library. Where we're struggling right now is getting sort of the right incantation. Incantation is the right word here. The right incantation to get the client set up and then to connect properly and to get that to actually work. But yeah, good question, Cake.js. I hope that made sense. Tell me if I need to explain anything a little bit more. And Likert Boy, a while loop that is controlled by the user ends with a blank value. A sentinel, a running total, the end condition counter. Are you asking me like test or quiz questions here on the stream? That's all I know. I'm struggling and just asking. Yeah, I think Cake.js is right. I think Sentinel is right. And frankly, that's not terminology that I use every day. Good question. I think Sentinel's right. It's not a running total. Interesting question. Cool. Okay, I'm back on the device. MQTT failed again. No. You're not a bother at all. Microboy, I was just joking about test question. It is not a bother. I am willing to answer anything. I will answer questions I don't even know the answer to. That's how willing I am to help. You're not bugging at all. Thanks for coming and hanging out. I do appreciate it. Yeah, Cake.js, definitely do. So there's some, I'll share some docs here on this. And hopefully when I get the other piece of this done, I'll write a blog post about this and get it all put together. But if you actually go to the Azure IoT Hub integration right now, here are the docs on that actually has everything on the particle side. Been shuffling things into Prometheus lately, and a nicer dashboard would be cool. Yeah, I love how easy it is to do the Electric I/O dashboards, and I want to pull that back on the other side to actually now allow functionality to come in on the other end. So this is where I am right now, and yeah, Siva, I think where we're at right now is that there's some like magic. There's some magic here that's missing in terms of how this is being instantiated. And I wish that the MQTT library gave me more than just. What does isConnected actually do? Let's do that. No, it's just underscore client dash connected. Okay, well, silliness. So what is client dot connected? Oh, okay, so this is the connected method of the TCP client. The actual TCP client itself that MQTT is wrapped around. So that's the piece that is the magic here that I gotta get figured out. And so I'm not gonna flail around anymore on this today. What I'm gonna do is as an idiot, and I didn't stash my other stuff, so I'm gonna comment this out for now. And we're gonna move on to some other firmware pieces. I'm gonna do my homework off stream to figure this out, and then I will on Thursday show you what I did wrong. Thanks, Eva. Yeah, have a good rest of the day. Thanks for joining, and thank you so much for helping. I feel like we are like just this close. We're so close on this right now, but I don't want. I also feel like I'm at a point now where I need to do a bit of like reading and ingesting, and then I'll have my aha moment. I'm having one of those like developer like walk away and you'll find the answer when you come back kind of moments. So Thursday, let's pick this particular item back up on Thursday. And in the meantime, let's actually mess with some other pieces. It would be kind of fun. So like the battery level stuff, let's get back to that. Because this is actually something that I'm doing on the screen now, and I'm gonna make it bigger. And yeah, if you figure out, you'll ping. Eager to look at why simple MQTT client didn't work. We're so close. Yeah, it is. It feels like a fix, like a missing semicolon, or something that's just out of whack. So definitely, and please do if you get inspired. I would be more than happy to hear it, Siva. Thanks again, though. Safe travels home. All right, so what I'm doing is I'm actually, so now I'm switching gears over to the battery stuff. I'm going to make this larger on the screen so that you all can actually see what's going on. But in order to get the battery level, I'm just doing an analog read on a battery pin. And then doing some, in our docs, in the particle docs, there's some info on converting the analog value into a 3.7 volt base that's coming from a LiPo battery. So that's why that's there. And then the actual print piece is further down, right? Maybe. Where's my, there we go, display voltage. So let me make this, gosh, even larger so y'all can see it. And I'll flash that real quick. It's probably going to be too big, isn't it? Dang it. But it's showing up. The actual value is showing up right here at the top of the screen. And right now it just says 3.7. I want to turn that into a percentage. So that's the piece that I'll mess with now here for a second. So that's going to be me basically dividing the voltage by 3.8 and then multiplying that by 100. That gives me my percentage value. However, I want to round that into a full number or into a whole number because it's going to give me something. I don't know if I'm reading it. So here's some voltages that are coming across right now. 3.69, 3.79, right? So if I do like, if I do something like 3.697186 divided by 3.8, it gives me, and then multiply that by 100, I want 97. I want to round it. Round it up or down, right, 5 over. So either give me 98 or 97 based on the actual value that's coming in. So that's the piece that I want to mess with right now. And I cannot remember. It's pulling those voltages a lot. Oh, it's because I keep resetting, isn't it? Yeah. So there's so many tabs open right now. I'm trying to remember the rounding. I have to remind myself of this. Right. Yeah, that's it. And it's right there. Thought I had to do something else. Isn't there a precision value that you can do for rounding? It doesn't matter. Oh yeah, you can see it now. So it's huge at the top of the screen, but that 3.7 garbage and then percentage because I'm not doing anything with it. So I want to take this, round it. Age monkey, hey, add 0.5 and cast to int. Really? It makes sense. See what I get from this. So what's funny here is that these batteries, these are actually like, these LiPo batteries are 3.7 volts, but when they're fully charged, they actually give you something more. They actually show you a value that's closer to 3.8. Or at least that's what I'm seeing from the voltage divider that's built in to the device. All right. Is that right, Grovard? 4.2 volts when full? I did not know that, but thank you. That makes a lot of sense. So rather than, I need to be closer to this. 4.2 times 100. Thank you. Bad math, Brandon. All right. Do I have something on the screen? Around 3.3 volts when dead. I knew that part. All right, so now what's showing up on the screen, I don't know if y'all can see it. I'm gonna see if I can get closer without this camera freaking out. God, it's just not like getting close up on the screen. All right, as it tries to adjust. I promise you that says 98.00. 98.00, okay. So Age Monkey, the average is 3.7. So is that actually why these are listed as 3.7 volt batteries? Because of the average value? There's another, I did not know that. I learned so much from y'all on this, thank you. That's cool. Yes, Age Monkey, the problem is the curve is not linear, so doing a percentage is not so simple. Yeah, you're right about that. However, hobby project, so I'm gonna just pretend. I'm gonna pretend like the math is good enough. But that is a fair point. I mean, when you're doing, and that's actually why on a lot of devices there's actually a power management circuit on there. Curves, Grover, the curve isn't linear, but it's close enough for an idea of battery level. Yeah, I mean, the big thing here is that I ultimately want these devices to run kind of unsupervised. Like right now when it's doing the fermentation, not right now, but when it's brewing beer, it's going to be pretty active. But when I've like got it in a closet and it's waiting for fermentation to start or measuring fermentation rates, the important thing is for me to get a notice when the battery falls underneath a certain level. So 40, 30, 40%, something like that, which is another piece that I want to track for sure. Yeah, there's just a simple voltage divider in here now that calculates the battery level, so it's not super precise. There's not like a PMIC in these devices because they're prototyping devices, but all right, so I'm getting some semblance of a value. I'm getting 98.00, but I want to drop the final to they're not in round precision. No. So this is the part, Age Monkey, where you talk about casting to an int. I'm going to close some tabs. Y'all don't mind me for just a second, because I feel like I am so many tabs open. Get rid of the round. All right. You're not doing it all? I see. You're saying, I mean, I basically achieved the same result through this. Casting will give me the same thing. Okay. Let me, crud. Yeah, yes, order of operations, thank you. Sorry, I was just about to reflash anyway. Let's get those correct. Why are you adding, no, that's okay. Don't apologize to me. You're the one having to watch me write this crappy code. Okay, so I'm gonna add, explain to me why I'm adding 0.5. Is that just to prevent the need to round? Regardless, I'm gonna get, sort of taking the rounding out of the picture. Cheap round. A cheap round. I like that. I like it. Tips and tricks. That's a good tip. Thank you. Thank you, Age Monkey. All right. Okay. So that's more like it. It's gonna reflash again because I just made that last change, but I'm getting, it should show up on the screen much larger here in just a second. And then I'm gonna go back and make it small again. It comes back online. Yeah. 138%. I think that's right. No, that's not correct. That's what I want. Right? Hold on. Where's my mind? Really? Plus 0.5. We should do that anyway. It should not be necessary. Which takes us back to what you had. No, actually. Yeah. 0.5 is after the percentage. Oh, I got you. So I got 138 because I was adding 0.5 times 100. Yeah. So 0.5 is after the percentage before the cast. For the cheap cast. Ooh. So that's not necessary. No, I guess so. All right, let's try that again. We're getting there. We're getting there. Okay. So when that is done, I'm gonna, if this is done. Once it flashes and we get the right reading. I think the next piece will be to come in and actually add some notifications on a low battery. We'll do it via the cloud, and it's gonna be a tough one. Well, not tough to test, it's fine. All right. There we go, we're back in business. Thanks for the assist, Age Monkey. I appreciate it. So I'm gonna go back down. I'm gonna go small on this, really tiny. And then come back up. Yeah, it's back on. Oh, still going. It's taking a minute. So when I am checking the voltage here, I'm going to do a, if the voltage is under 30%. Show a low battery message and then publish a message to the cloud. In the meantime, yeah, so that's much smaller. That's what I was going for. Something relatively unobtrusive that's going to be there throughout. Right now it is positioned a little bit closer to the edge. And so I actually might, for the purposes of doing my calculation here, I think I might actually want to move this out to here. I'm going to move this to actually where the voltage is being calculated. So I'm going to go up to where I'm reading the voltage, and instead of returning here, I'm going to return an int when I call check voltage. No. So, and then where I am calling check voltage, I will, let's see, int. So I have a value under display voltage now. Should be another place where I'm doing that. In my loop. All right, so now I will have a whole number here that I can check. So if voltage is less than, let's just do 90 for now. And here, this is what I'm gonna set this as a constant. Or a replacement value. What's this? So now in my loop, if where'd I go? If that voltage is under the low voltage literal, then I will display low bat alert. Is not there yet, and then we'll do a particle publish. We'll do an alert. All right, so let's come down here where we have defined display voltage, and we will do a display low bat alert here. And this one should be relatively easy, so I'm just going to do tft.setCursor. One down just a tad. Set text size to 2, and the color here will be red. I'm using that elsewhere, that red color on the graph, so let me double check. Yeah, I am. Wait, what? That's a bug. Huh. Never noticed that before. Okay. I am using that though. That is correct. So let's set that to red, and then we'll do tft.println. Just like that. I'll show up on the screen as a low battery alert. So let's flash that. And as I'm sitting here waiting for that, I'm thinking to myself, like, I have these methods that I defined as display voltage. It's not a voltage anymore, it's a percentage of charge left in the, so I gotta change that. But not right this second. Did that fail? Must have. Compile. I saw it. I saw the error. Where'd it go? Oh, silliness. Oh, what is this? JavaScript? No semicolon? I write a lot of JavaScript, so I can say that. Cake.js, any plans for choice of sleep mode? I recall the deep sleep current numbers being really impressive on Gen 3. Yeah, Cake.js, actually I am. I haven't demoed this specifically today, but the other mode that I have in here is I actually am using sleep modes during fermentation. So if you set the device to fermentation mode here on line 374, let's do it. On line 374, I'm actually putting the device to sleep. And I can demo that here in just a second. But what actually happens is it listens for a pin, it listens for a wake up on this, this piezo disc that I have that's connected to the device. And this disc will sit on top of the airlock of the carboy, and it's calibrated hopefully to where when fermentation actually starts, it'll knock that device and it will actually cause a change in voltage on that piezo disc and cause the device to wake back up. So that's what I'm using for sleep modes, because my goal is once I'm brewing, like when brewing is done, it's 24 to 48 hours before fermentation starts. So I know that there's going to be a day or two where I don't need to read anything, but I want to have the device connected so that I know when fermentation actually starts. So by using that, by using sleep modes, I can hopefully get some really, really low power readings out of the device, and then just kind of go from there. Run off that same LiPo for a longer period of time, which would be really sweet. So I don't know if that answered your question, Cake.js. I think it did, but let me know if it didn't. Okay. So thank you. Yeah, cool way to wake it up. It could only be done with an IC timer. You can do a timer as well. In fact, there's even a way that you could use a timer plus an external wake up pin. So it's possible to say, wake this up immediately on an external trigger, external pin trigger, or wake it up after 60 minutes or 60 seconds, or whatever. You could do a combination of both. In my case, I'm only doing on the wake up pin because that's the thing that I wanted to do. So yeah, let me show you actually. I'll demo this right now because it's pretty neat the way that it works. So I moved into fermentation mode here, and you'll notice actually that the LED on the device is off. I'm actually now in sleep mode fully. So what I can do is I will actually tap this disc, and that will wake it back up. If I tap the piezo, that actually brought the device back awake. And it says, you know, it gives me sort of an idea of how long it took to go into fermentation, and then it reconnects to the particle device cloud. And it actually publishes a message saying, hey, fermentation has started, and then I start tracking the rate of fermentation, how often the piezo disc gets tapped. It's pretty cool. I am looking forward to a real world test for this really soon, once I actually get everything sort of working here. That means I gotta brew some beer, but you know, I was looking for an excuse to do that. It's important, testing things that I've got to do, right? And that fermentation rate, well, it's supposed to, would show up in here as well. If I hadn't, oh yeah, so it's showing up as a 0. Why is it 0? I gotta figure that piece out. Yeah, that's what's happening right now. Okay, Jess, good question. Thank you. Yeah, it reminds you of outdoor solar installs with knock sensors to switch the display stats. Oh yeah, cool. Yeah, it's exactly. Yeah, it's a perfect way to describe it. I lose my train of thought. So I was supposed to, anytime I get I just noticed in fermentation mode that my battery display is not showing anymore, which is kind of annoying. So I'm gonna have to make sure that that's still there. But let me switch back into brewing mode. battery thing is not still there. All right, well, hey, this is why we test, right? Find bugs. Load. I think I know why. Because I'm clearing the entire screen. So what I probably should do is just reserve like the top 20 pixels, that band across the top, to be sort of my status bar, and not wipe the entire screen every time I make a big change. Because that's what's happening right now. All right, well, in the few minutes that I've got left here, oh yeah, it's checking that right there. Checking it based on the battery interval, which is not very frequent, right? So for testing, I need to change my battery interval. For testing every like 5 minutes. Just want to see it, see what it looks like, see that it's working, and probably, oh yeah, I'm almost 2 hours in, so I gotta wrap up here in a little bit too. So I gotta be thinking about who to raid, who to say hello to. We're flashing. We're flashing. Okay. Come on, come on, come on, come on, come on. I want to see it working. I don't know why I keep getting this message saying that it failed to flash when I see it here behind me. It's actually flashing. That's okay. All right, so yeah, that should show the alert when it finally gets on there. It should be checking that. Low bat, there we go. I got my low bat message. And did I get an error? Low bat. I can see it. It's on there. You can see, I'm sure, some blurry text. Here, let me go up bigger here since I can't get the stupid camera to focus. You can see low bat and blurry text. It's not red, but that's okay. So I need to fix that because can I not set? Huh. Yeah, display low bat alert. So let's go back down. Oh. I did it to myself again. Set text size, not set text color. Right there. The exact same thing I've done before. So 3. Cloud flash. Okay. Let's flash it one more time, and then I'm going to clean a couple of things up. And yeah, we can go ahead and, by cleanup mean remove some things I hard-coded to check these levels. But that's what I want ultimately, is a low battery alert. Oh, and actually, you know what? Maybe I should put it on the left-hand side here as I say this to myself as I flash it again. So do it on 10, but maybe 20 pixels over. No, it's fine where it is. Just leave it where it is. There's no point in... I'm not gonna mess. I'm not gonna mess around. Age Monkey, that is a great question. When you go to sleep, did you turn off the display? And you know what? I don't think I did by default. So I need to make a note to do that as well. Or at least make sure I am. Very good question, because that will impact everything. If I'm still, well, that's gonna, goes against cross purposes of what it is I'm trying to do, right? If that's how it rolls. All right. Should be in just a minute. For it to turn the text. So I gotta set it back to white after I actually do that print line. And I didn't want it that big. I thought I said it's 2, not 3. Okay, 2 should be fine. Okay. No, so this is pretty good. Yeah, display is definitely sucking the most power, so that's a good note, Age Monkey. I appreciate it. Now y'all can see low bat. Okay, so you're seeing that it is showing up, which is great. While that's going, I'm going to clean up some of the things that I hard-coded in here, or some of the changes that I made here. For the battery check, I am going to kicking myself for not committing some of the MQTT stuff and stashing it so that I don't have it here, but it's, you know, it is what it is. It's fine. Oh yeah, my battery low voltage. I think I want to go under, just call it under 30. We'll do the message at 30. And then I am going to check all this in. Take a look at my items here. Closes number 38 and closes number 35. So that's good. And I pushed, which is going to trigger a build here in my Azure DevOps pipeline that will compile and run the firmware. So that'll be good. And then I can move these. Here. And let me check. I think we got, I need to move it over a little bit, but we got the idea. It's working, it's looking good. That is my stopping point for the day because I need to be done. Got some stuff to take care of. So thank y'all so much. This was actually a lot of fun. I really enjoyed working on this today. I know we didn't get everywhere with the MQTT stuff. At least we got to wrap up, have some wins on the firmware side. So thank you, Age Monkey, for the help on that regard. GrowGuard for your input on that as well. CakeJS for the questions. And Siva, I know you're gone, but thank you for the help on all of the MQTT stuff. We're going to get to that next time, which will be good fun. And in the meantime, we're gonna raid over to Mr. Robert Tables, who's doing some cool stuff and is a fantastic streamer. So y'all have a great rest of the day, and I will see you again on Thursday. Bye.